Okay, let us discuss about the application of derivative. In application of derivative, first we describe about the increasing and decreasing function. So what is increasing function? A function f is said to be increasing on the interval I, if x1 is less than to x2. If x1 is less than x2, then the result become f x1 is less than f x2. Then the function is called increasing function in the interval I for all x1 x2 belongs to I in the interval I. So in the graph we can represent that let the function be your x1 and x1 is less than x2, so x2 should be greater, and then the curve passing through this line, the image of x1 is f x1 here, and the image of x2 is f x2. So when x1 is less than x2, f x1 is less than f x2. This is called increasing function in the interval I. And similarly another function is decreasing function. Decreasing function, and the function is said to be decreasing if x1 is less than x2. If x1 is less than x2, this implies f x1 is greater than f x2 for all x1 x2 belongs to I. Then the graph you can plot according to it. So the decreasing function is the function is said to be decreasing if f x1 is less than x2, then f x1 is greater than f x2 for all x1 x2 belongs to I. And monotonic function. What is called monotonic function? I will write here monotonic function. A function f is said to be monotonic on the interval I if it is either increasing or decreasing on I. If the function is either increasing or decreasing on the interval I, then the function is said to be monotonic function. Okay, I will give some example so that it will be clear about the concept of increasing and decreasing function. So question, so that fx is equal to 6x plus 1 is increasing for this is the question. We have to show the function fx is equal to 6x plus 1 is increasing. So let x1 x2 belongs to R such that x1 is less than x2. This implies if x1 is less than x2, we can write here, then 6x1 will be less than 6x2. Okay, it is easy. Then when we add 1 in both sides, it will be less than this. If it is less than this, and when we add the same number in the both sides, then it will be less than the second function. So this implies this is fx1 and this is fx2. So fx1 is less than fx2. Okay, x1 is less than x2. Then when we multiply 6 on the both sides, the result will be same, that is less than. And when we add same number in the both sides, then the result will be also same, that is this side is always less than this side, and it represents the fx1. Okay, here x in place of x there is x1, so this is the image of fx1, and this is the fx2. So We assume that x1 is less than x2, and we came to conclude that fx1 is less than fx2. So the function is, therefore function is increasing on the interval I. So the function is increasing on the interval I. Okay, then another topic is the test for monotonicity. Test for monotonicity. So for the monotonic function, a function y is equal to fx is increasing in the interval a comma b if f dash x, that means second derivative, is greater than 0 for all x belongs to a comma b. Okay, for the test of monotonicity, a function y is equal to fx is increasing in the interval ab if f dash x is greater than 0. That is, if the second derivative is greater than 0, then the function is increasing, then the monotonic function is increasing. So then the for decreasing function, f y is decreasing in the interval if f dash x, that is second derivative, is less than 0. If the second derivative is less than 0, so the function is decreasing in the interval x belongs to a comma v. So we can test the monotonicity of the function in this way. Okay, then another important thing is critical point or stationary point. We can just say anything, it is either it is critical point or stationary point. So a point in the function y is equal to fx is said to be critical point if f dash x is 0 or f dash x is undefined. So the point in the function y is equal to fx is said to be critical point if the second derivative is 0. First derivative is 0 or first derivative is unidentified or undefined. Okay, so we can conclude that if the first derivative is greater than 0, the function is increasing. First derivative less than 0, the function is decreasing. And when the first derivative is 0, either 0 or undefined, then the point is said to be critical point. So here is the one question. By doing this question, the concept will be clear. We have to show that the function x cube minus 3x square x plus 3x minus 100, that is minus 100, minus 100 is increasing on r minus 1, that is it is the increasing on all real number except 1. So given fx is equal to x cube minus 3x square plus 3x minus 100, then we have to calculate the first derivative. So first derivative is 3x square minus 6x plus 3, and when we take 3 common in this algebraic equation, then x square minus 2x plus 1, then 3x minus 1 whole square, and it is greater than 0 for all x belongs to r minus 1. So when x is equal to 1, it will be 0, so except for 1, it will be greater than 0. And we can conclude that if the first derivative is greater than 0, then the function is increasing. Another question, examine whether the function fx is equal to 15x square minus 14x plus 1 is increasing or decreasing at x is equal to 2 by 5 and x is equal to minus 2 by 5. The given function is fx and the first derivative is 330x minus 14. Then if when x is equal to 2 by 5, then f dash x is equal to 32 by 5 minus what is less than 0. So fx is decreasing at x is equal to 2 by 5 and greater than 0 increasing. And another question, find the interval for which the function fx is x is plus 1 by x is increasing and decreasing. Given that fx is equal to 1 plus 1 by x, f dash x first derivative is 1 minus 1 by x square. Then for stationary point we have second first derivative is 0, so x is equal to minus 1 since the function is undefined at 0. So the points, so the point that divides the line are minus 1 0 1. So interval minus infinity to minus 1 and minus 1 to 0 1 to infinity, then sign minus minus plus. So the function increasing at minus infinity to minus 1 union 1 to infinity, decreasing at this interval.